Hello, everyone. Welcome to the course Foundation and Substructure Construction. I am today instructor Wang Shiyang. Let us study today's keyword, prefabricated pile hammering method construction. There are two core terms here. One is prefabricated pile. The other is hammering method. We have already learned about prefabricated piles before, so you should compare them with cast-in-place piles. The hammering method is a way to put prefabricated piles into the soil. In common prefabricated pile construction, according to the method of driving the pile into the soil, it can be divided into hammering method, vibration method, static pressing method, etc., among which the hammering method is the most commonly used construction method. In this study, we will learn about the prefabricated pile hammering method. This naturally leads to the task of today's lesson. Before formally learning the hammering method, we first need to know the production steps of prefabricated piles. For the hammering method, in particular, we need to know the process flow and construction key points. Let's begin. First, let's study the production of prefabricated piles. The specific construction process is as shown in the diagram. Since the prefabricated piles learned in this chapter are mainly reinforced concrete piles when making them, the order is still formwork, reinforcement, and concrete. During the learning process, you should especially pay attention to three concrete strength levels. 1. When the concrete strength reaches 30% of the design strength, the formwork can be removed. 2. When the concrete strength reaches 70% of the design strength, it can be lifted. 3. When the concrete strength reaches 100% of the design strength, it can be transported and stacked. This data needs to be firmly remembered. In addition, there are some key points in concrete production, briefly introduced here. 1. Prefabricated concrete piles can be prefabricated in a factory or on site. The prefabrication site must be flat and solid, and the formwork used should have sufficient rigidity. 2. The concrete strength grade of prefabricated piles should not be lower than cast 30, and the thickness of the longitudinal reinforcement protective layer should not be less than 30 millimeters. 3. The reinforcement arrangement of the pile body should be determined according to the conditions of lifting, pile driving, and the forces during use. 4. Long piles can be made in sections. The sectional length of prefabricated piles should be determined according to construction and transportation conditions, and the number of joints per pile should not exceed 3. 5. The main reinforcement joints of the reinforcement cage should preferably use butt welding or arc welding. When the reinforcement diameter is not less than 20 millimeters, mechanical connection should be used. Next, let's look at the construction process flow of prefabricated piles. Setting out and positioning the pile driver, lifting the pile, stabilizing the pile driving, pile joining, pile pitching, inspection, and acceptance, PO cutting. When setting out the pile position, note that the pile position line should be marked according to the axis line. The pile position should be fixed with wood or reinforcement ends and marked with line for easy driving. When positioning the pile driver, note that it should be aligned with the pile position to ensure vertical stability, preventing tilt or movement during construction. When lifting the prefabricated pile, note, First attach the lifting steel wire rope and locks. Then fasten the lock to the lifting ring at the top of the pile. Then lift the prefabricated pile so that the pile tip is vertically aligned with the pile position center. Slowly lower it into the soil. Ensure the position is accurate. Then place the pile cap or pile hoop on top of the pile and remove the locks. After the pile tip is inserted into position, use a smaller drop height to hammer once or twice to make the pile vertical and stable. For short piles within 10 meters, usually use a plumb bob for two-way alignment. For piles over 10 meters or during pile joining, a plumb bob or theodolite must be used for two-way alignment. Visual estimation is not allowed. The verticality deviation during pile insertion shall not exceed 0.5%. Before pile driving, a measuring ruler should be installed on the pile frame to facilitate observation and recording during construction. During pile driving, note, when using a drop hammer or single acting hammer, the maximum drop height must not exceed 1 meter. When using a diesel hammer, ensure normal hammer jumping. Pile driving should use heavy hammer and low blow. Hammer weight should be selected according to engineering, geological conditions, pile type, structure, density, and construction conditions. The pile driving sequence should be based on foundation, design, elevation, deeper first, then shallower, based on pile specification, larger first, then smaller, longer first, then shorter. According to pile density, driving can be done symmetrically from the middle to both sides, from the middle to the surroundings, or from one side to the other. When joining piles, note, when the pile length is insufficient, welding joints should be used, and the embedded parts must be clean. The gap between the upper and the lower sections should be filled with iron sheets and welded firmly. Measures should be taken to reduce weld deformation, and the weld should be continuously full welding. Pile joining should generally be done about 1 meter above ground level. The centerline deviation between upper and lower sections shall not exceed 10 millimeters. Before the joint enters the soil, exposed metal parts should be coated again with anti-corrosion paint. When the design requires pile pitching, the centerline of the pile pitching hammer should align with the pile body before pitching. If the pile top is uneven, use sacks or thick paper to pad it flat. The hole left by pitching should be filled and compacted in time. When each pile reaches the required penetration and the elevation between piles, enters the bearing layer, approaches the design elevation, or reaches the design elevation, an intermediate acceptance should be carried out. Control is generally based on the average penetration of the last 3 blows not exceeding the specified value, or by piles reaching the design elevation. Once meeting design requirements, fill in the construction record. If a large deviation from the required pile position is found, relevant parties should jointly decide on treatment, then move the pile driver to the new position. After all piles are driven, excavate to design elevation, and carry out final inspection and acceptance. To connect the pile body and the pile cap into one, a pile cutter or pneumatic pick can be used for pile cutting. During operation, avoid cracking the pile body concrete and strictly control the pile top elevation. Concrete blocks attached to the main reinforcement should be removed in time. Let's summarize this lesson. In this lesson, we learned the process and the key points of prefabricated pile hammering method construction for a complex construction process. Engineers often break it down into several or more than 10 steps. This is the process thinking of engineers. A complex task is often composed of multiple process steps. Optimizing each process step to the best level is called full process optimization. The concept of full process optimization seems ordinary, but its greatest feature is the ability to create miracles in the ordinary. I hope that all students, based on learning today's content, can also apply process thinking in life to implement self-improvement. That concludes today's lesson. I hope you all will find it beneficial. Thank you.